All right, so now I'm going to talk about some of the characteristics of neural networks, some of the things that follow from neural networks. One of the things about neural networks is that they assume that processing is parallel and that processing is distributed across the neural network. And this is in contrast to a lot of information processing models, where those kinds of models assumed that this process occurred, and then only after that process is finished can another process begin, right? So that processing is done in stages or serially. Uh, that's what we mean by that. However, it does in neural networks, the processing for everything can occur at the same time, as opposed to serially. It also assumes neural networks also assume that processing is distributed throughout the network. It's not like there's this one unit that does this and then another unit that does that. It's that the whole network does a bunch of different things. It also assumes that learning is error-based, and this is definitely in contrast to a lot of information processing models that don't actually really seem to give much attention to learning or development. It doesn't even really they often do not ask the question of, how does cognition work as we develop? Whereas for neural networks, this is pretty straightforward. So at the beginning, the values of the weights will change a lot because errors will be super frequent, right? So when you're a baby, or a toddler, the values of the weights will change a lot because errors will be super frequent. However, as the weights change, with subsequent learning, the errors will decrease, which means that the value of the weights will begin to converge on a particular set of values. So as you age, right, the errors will decrease, which means that the value of the weights will begin to converge on a particular set of values, and you'll start naming pictures correctly, right? Okay. For example. Um, yeah. And then it also assumes that representations are emergent. And I'll elaborate on this in a second, but the fact that the representations are emergent, this can explain generalization in learning, but it can also explain graceful degradation and functionality after brain damage. So, what do I mean by emergent? I'm going to talk about what I mean. So, let's do that. Here's a Budweiser commercial, right? So, as you can see, everybody's hanging out. They got a sign, they put the sign up. And when they put the sign up over their heads, it makes up a Budweiser bottle and a glass that's pouring the beer into the Budweiser glass. And so this is what we mean by representations being emergent. Individually, each sign means nothing. Let me pause that. Okay. Hopefully, I didn't encourage drinking. So individually, each sign means nothing. But when you put them all together, the picture emerges. And so this right here is a Byzantine picture from Hagia Sophia in Istanbul. And those are tiles. Each one, the picture is made up of a bunch of individual tiles. And individually, they mean nothing, but when put together, a picture emerges. This is also true with this picture from a Jim Carrey movie. And these make up Jim Carrey from the Truman Show. And these right here make up Yoda, right? So similarly, in the neural network context, each node or unit in a neural network means nothing. But when the nodes or the units combined, the representation emerges from the collective pattern of activation that is distributed across the network. And notice how if I get rid of a subset of these tiles or a random subset of these pictures, it wouldn't really have much of a big effect on the representation. I'd still be able to perceive Jim Carrey if some relatively small percentage of random pictures were taken out. So that's what we mean when we say that representations are emergent. This also explains what we call graceful degradation in learning, because basically, if you have brain damage or as you get older, right, your brain sort of degrades in quality. The quality of your brain gets worse. That's just what aging does to everybody. And in that context, your performance is going to get worse. So as you get older, you're going to get worse. Or if you have some brain damage, you're going to get worse. But let's just take yeah, so neural networks explains that if some of the nodes are destroyed, that's not going to have a big effect. It's not like it's going to make the task impossible. People can still do it. They just might not do it as well or as fast or as accurately as they would have otherwise. And this is also true with brain damage. So if people have brain damage, it's not uncommon for people with brain damage to have some amount of functionality still preserved. In a neural network, if some of the nodes are destroyed, the neural network will simply make more errors or work more slowly, but it may still be able to do a given cognitive task. And because there would be a lot more error if some of the nodes are destroyed, the connection weights would readjust and try to compensate for the loss of other nodes. This is similar to neuroplasticity, where the brain can sometimes rewire itself after brain damage. Okay, so the information processing approach, in the information processing approach, representations are usually symbolic, not always. However, for neural networks, the representations are commonly referred to as non-symbolic. So information is represented by patterns of activity rather than symbols. And this is in contrast to the previous sort of information processing approach models. The other thing is that in many information processing models or symbolic models, it's usually the case that the processing that occurs is distinct from memory, right? So in the previous way, in the information processing approach, memory is sort of thought of as a store, like a place where you store your memories, right? So you store the memory somewhere in your mind and then you process it. But that processing is independent of the memory storage, right? So you retrieve the memory from your store and then you process it. However, in a neural network model, processing and memory are one and the same. So if you want to remember something, you need to activate those nodes. So memory is really just activation of nodes, which is essentially processing under a neural network framework. Okay, so in the next video, we'll talk about criticisms of neural networks.